Take your seats. Good morning to all of you and good morning to all those who have joined us online. So friends, let's try to understand first today in the class two basic concepts. And these are very simple concepts. We'll just have them as reference point as we move forward. The first thing is isotherm. The second one is isobar. Now, the word iso means similar. Therm means temperature. Bar has an indication towards pressure. So isotherms are imaginary lines joining places having equal temperature. Like say, for example, we have temperature curve, say 30 degrees Celsius, and at some other place, again, 30 degrees Celsius. So this is point A and point B. If I draw an imaginary line that join these two places, I'll call it a 30-degree Celsius isotherm. And we will see that how these isotherms play a vital role as far as the Indian monsoons are concerned. Okay. And what is isobar? Isobar is an imaginary line joining places having equal pressure. Like so, for example, another place called C and fourth place called D, they have equal pressure, say 2 millibars, 2 millibars. Then an imaginary line joining these two places. There are actual lines drawn on the Earth's surface. These are imaginary lines like latitudes and longitude. So an imaginary line joining two places having equal pressure is the isobar. Right? Very simple concept. No rocket science in this. But this becomes very crucial when we take into context something called the differential heating. Differential heating of land and water. Look here, very carefully. The land heats up quickly and cools quickly, whereas the water heats up slowly and cools slowly. Why does that happen? First, take a look at this. Suppose this is land surface and this is water. Let me take the same cross section for both land and water. Okay. Now imagine that there is an incident ray of sunlight. Let's assume that the ray is incident upon both land and water at the same angle, because this angle is theta, then this angle is also theta, and for the same duration, say t. T is the time duration. It means the angle of sun rays and the length of the day, both are constant in both the cases. Only thing that differs in these two cases is the surface over which the ray of light is incident upon. Now, land is opaque. It won't allow light to travel to lower layers. That's why all the heat would get concentrated at the top layer. There would be definitely some transfer of heat to the lower layers, but this would be conductional heat transfer. And what kind of conductor are rocks or soil? Are they good conductors or bad conductors? Very bad conductors. Do you understand that? Like in summer season, you will see that if there is a big rock and it's a scorching day, high sun beating the ground properly, if you just take that rock and if you you turn it upside down, you'll find in the lower section of the rock, there could be some moisture. That's why you'll find some insects who would be hiding in that lower section of the rock. Why? Because rocks are very bad conductor of heat. If this would have been a steel box, then the insects would never take this refuge. Okay? Now, look here. So, land is a very bad conductor of heat, and that's why there is very less heat transfer to the lower layers. That's why the top section of the land remains hot or relatively hotter when compared to the lower sections. The things completely change when we move to water. Water has some degree of transparency or at least you can say water is, if not transparent, it is translucent. Okay, so some amount of energy would penetrate to a particular depth. Beyond the depth, sunlight also cannot penetrate in water. And because we are moving from a rarer medium to a denser medium, so the ray of light will turn towards the norm. Okay, so this angle would be, say, phi, where theta would be more than phi. And again, nothing but the Snell's law, and this action is refraction. So now look here, the same amount of energy is getting distributed between layers. Because this layer 1, layer 2, layer 3. So at any given point in time, the total amount of energy concentrated at the topmost section of water or at the water surface would be relatively less when compared to land. If their whole ceteris paribus means all the other factors are constant. It means the angle of sun rays, the length of the day, etc. held constant. Water will take more time to heat. You get that? Also, there would be a lot of mixing of different layers of water because water is mobile. It's liquid, whereas land is solid and the molecules cannot move. If that's the scenario, then I can very safely say that land heats up quickly. When compared to water. And the biggest representative of land on the surface of the earth are continents. So I can say that continents heat up quickly when compared to ocean. Do you understand that? That's why if it's a summer day and you enter into a swimming pool or a pond or something like that, you'll find that it is much cooler when compared to how the temperature is outside the pond or the swimming pool, whatever the case might be. Now, what happens when we are thinking of the release of this heat? During night, you can understand that the land will lose heat in the form of outgoing terrestrial radiation. The same thing will happen with respect to water as well. Water will also lose heat by outgoing radiation. Sorry, I'm not calling it terrestrial radiation because there is no land involved in this, but you can club them as OTR, both of them, for understanding. Now look here, because we know that all good absorbers are good emitters, the land will lose heat at a faster rate. And in fact, the atmosphere, the cold air, when it will come in contact with the hot land during the evening time, the land will start losing heat to the air. And by late night, the land would become very cool. Say somewhere around 12 a.m. or 1 a.m., the land would start cooling. By 3 a.m., it would be very cool. And if it's a winter season, then dew might also develop over land. But when it comes to water, you see, the air parcel which is in contact with the topmost layer of water, or the air parcel which rests over the water surface, the surface will lose heat to the air parcel. But also you must keep this in mind that there is mixing of layers that keeps on going in water. So if this layer loses heat, the other layers will transfer heat to this layer by the way of conduction and will not allow the topmost layer to cool down very quickly. That kind of a leverage land does not have, because at lower layers there is not sufficient heat, because in the first place there was no sufficient heat transfer to the lower layers. Why? Because land is opaque, whereas water is translucent, if not transparent. So land will also cool quickly. Land cools quickly when compared to water. I can say this, that continents heat up quickly when compared to oceans and cool quickly when compared to oceans. This phenomena is known as the differential heating of land and water. If I have to put it more technically, I would say that the specific heat of water is more than the specific heat of land. You get that? What is specific heat? Specific heat simply means the amount of heat energy required to raise the temperature of a body by 1 degree. Do you understand that? It means I have to apply more heat to water to raise its temperature by 1 degree, whereas I have to apply relatively lesser amount of heat to land to raise its temperature by 1 degree, because there is less distribution of heat between layers in land because of its opaqueness. Whereas When I come to water, I see that there is more distribution of heat. ठीक है, ये सिंपल सा टॉपिक है, लेकिन इससे क्वेश्चन कई बार आ चुका है, इनफैक्ट 3 बार आ चुका है इसी टॉपिक से क्वेश्चन. So do you understand the differential heating of land and water? Now, we think that the isotherms are straight lines, but the isotherms are not always straight lines because of this differential heating of land and water. Take a look at this. Suppose it's water surface and we are at a particular latitude, whatever the latitude, whatever you want to imagine, but it's pure water. Got it? Now, if it's the same latitude, then I can say very safely that the angle of sun rays would be similar. The length of the day would also be similar. Do you understand that? So here at a particular point, if I hold that the temperature is 30 degrees Celsius, if I go at the same latitude at any other point on water, I'd find more or less 30 degree Celsius. So this is point B. So if I join point A and B, I get the 30 degree marine isotherm because it is over the oceans. Do you understand that? Similarly, if I do the same exercise for land, there also I will find a straight linear line. Let's add some variation. Suppose in this latitude, as I go further, I encounter land. Got it? And then water continues. Imagine this is the summer season. If it's the summer season, you tell me, the land would be more hotter or the water would be more? The land would be. As I told you, land heats up quickly and cools also quickly. In summer season, land would be more hotter. In winter season, land would be more cooler. You understand that? That's why those areas which are away from the ocean will experience extremities of climate, like Delhi. Delhi experiences extremities of climate because it's too far from the oceans. When you go to Mumbai or Chennai, there is more moderating impact of the ocean, or Kolkata, you'll find more moderating impact of the ocean. But Delhi, far flung from the oceans, that's why harsh winters and scorching summers, they are typical to the Delhi weather. But anyhow, if it's the summer season and at this latitude, if we hold it anything like X degree north latitude, it could be anything. If the temperature of water is 30 degree, what do you think? The temperature of land would be more than 30 degree. Let me hold this as 35 degree Celsius. Okay, let's assume that I come to a lower latitude and I am in the northern hemisphere. Let's assume something like this, and let's assume for the sake of our understanding that there also there is some land water distribution. Got it? So if this is 35 degrees Celsius, I'm going towards the poles. Okay, suppose the equator. This is the equator, which is 0 degree. If I'm going towards the poles, then definitely the temperature must be falling. Got it? So if this is 35 degree, can I say this could be somewhere around, say, 30 degrees Celsius? Sorry, this could be somewhere around 40 degrees Celsius. Like the temperature is constantly falling. You understand that? And here also, can I say just by applying the same logic, this would be 35 degree Celsius. I'm just taking for mathematical ease, right? These kind of round figures. Do you get it? So as I move towards the north, in water also the temperature will fall. In land also the temperature will fall. Now if I have to draw a 35 degree isotherm, how would it look like? It would look like this. You understand that? So isotherm is not necessarily always a straight line. Obviously, if this is 35 degree, this would again be 35 degree, isn't it? And if that's the case, then this would be the isotherm, 35 degree isotherm. और हम देखेंगे when we will try to study monsoons, we will see that this is how an isotherm shifts due to differential heating of land and water. समझ में आ रहा है? उसकी बातें बाद में करेंगे, but यहाँ तक बात clear हो गई? Similarly, isobars, you can understand temperature and pressure has a relationship. High temperature generally produces low pressure zones and low temperature generally produces high pressure zones. So if here the temperature is 35 degrees Celsius, then can I say that here there would be relatively high pressure when compared to this would be low pressure? You understand that? So let me assume that here the pressure is 1 millibar. So I'm holding here the pressure would be say 2 millibar because the temperature is falling. Got it? And if here the pressure is 1 millibar, What do you think? Over water, the pressure would be more than 1 millibar or less than 1 millibar? अरे more होगा ना, temperature कम है, क्या कर रहे हो? So here would be 2 millibars maybe. तो यहाँ पे भी ले लेते हैं 2 millibar. ऐसे सोच कर देखो ना, यहाँ 2 millibar है तो यहाँ पे भी तो होगा. Isn't it? Simple logic. So you get the 2 millibar isobar. So isobars are also not necessarily straight lines. They can also be curved lines. And this happens due to the differential heating of land and water. Everybody has understood that I have discussed whatever in the class so far. Giving you a quick recap. I'm saying there are two important terms, isotherms and isobars. Isotherms, imaginary line, joining places having equal temperature. Isobars, imaginary line, joining places having equal pressure. Do you understand that? Temperature and pressure has generally an inverse relationship. Very carefully, I have used the word generally because we'll see that the subtropical high pressure areas are also the high temperature areas. So there are some exceptions to this. But generally speaking, temperature and pressure are inversely related. Higher the temperature, lower the pressure. Lower the temperature, higher the pressure. Do you get it? And we see that there is something called differential heating of land and water. Land heats up quickly and cools quickly, whereas water heats up slowly and cools slowly. Do you understand that? This phenomena is known as the differential heating of land and water, and this could be attributed to the specific heat of water. The specific heat of water is more than the specific heat of land. Specific heat means the heat energy required to raise the temperature of the body by 1 degree Celsius. मतलब ज़्यादा heat लगती है पानी को गर्म करने में when compared to land. You understand that? And we also understood that the isotherms and the isobars are not necessarily straight lines. Isotherms and isobars could be curved lines. Why? Because of the differential heating of land and now the baat clear hai? Is everything clear so far? Good. Yes, most of the times they are because there is a relationship between temperature and pressure. अच्छा चलो ध्यान से देखो ठीक है. We all know what is convection and we also know what is advection. What is convection? It is the vertical movement of air. It could be upwards or downwards. What is advection? Advection is horizontal movement of air. And you know that it could be at upper levels or at ground level. But you also understand one thing, that air will always move from higher pressure to lower pressure. So this must be higher pressure and this must be lower pressure. And you also know that air always rises from higher pressure and air always sinks at lower pressure. This is nothing but the convective cell, also known as mixing. This mixing keeps on happening in which layer of the atmosphere? Troposphere. Very good. So देखो अब ध्यान से देखो. We know that horizontal movement of air due to pressure differences is known as wind. So next thing in the class we will try to understand is the various factors that affect wind movement. ये बहुत important है. Again, if we are trying to understand cyclones, monsoons, etc. आप कुछ भी सोच कर देखो, इसके बिना समझ पाना थोड़ा मुश्किल है. So there are three factors. First is the pressure gradient force, or we call it the PGF. Second is the Coriolis force, and third is the frictional force. We'll take all of them one by one. What is a gradient? What do you understand by a gradient? What does gradient means? Gradient means a slope. Actually, gradient does not mean a slope. Gradient means the angle of the slope. Do you understand that? कई बार इस angle को और slope को we use synonymous. That's why we are saying gradient. Got it? Now, look here very carefully. Suppose I have a slope. Got it? And suppose I drop water at this point, at the top section of the slope. Do you understand this? That the water will flow like this? Water will flow like this. So if I drop water at point A, I can collect that water at point B. The amount of collection would depend on certain factors. Some of the water might get evaporated, some of the water might get percolated, and the remaining one will flow across the slope, and I can accumulate that at the foothill of the slope. Got it? If I tell you that I dropped water at point B and the water, it flew like this from point B to point A. Can you believe that? Can you believe that? Can that happen? No, this is anti-gravity movement, which is impossible. Do you get it? तो इसका मतलब क्या हुआ? It means all flows take from high to low. इतना समझ में आ गया ना? इलेक्ट्रिसिटी देख लो, एयर देख लो, वाटर देख लो. फ्लो के लिए क्या चाहिए होगा हमें? एक ग्रेडियंट चाहिए. You understand that? So, what is the pressure gradient? Pressure gradient is nothing but the difference between two places' pressure points. Got it? Like say for example, we have a place called A and the pressure here is 3 MB, and we got another point called point B, and here suppose the pressure is 1 MB. So if I suppose have these kind of markings, say 1 MB, 2 MB, 3 MB, 4 MB, 5 MB, 6 MB. You understand that? So I'll hold place A here, or where is place A here, and I'll hold place B here. Do you understand that? This is the gradient. Can you see? This is again a slope. This is a slope. So air will blow from high pressure to low pressure. This is more technical expression of it. अच्छा, एक बात बताओ मुझे, that this is slope over which I used to drop the water. Now its angle is theta. Let me give a value to this. Suppose this is 60 degree. Now I take another slope where the angle is 78 degree, and I drop the equal amount of water here as well. Water will flow down the slope. In which case, case 1 or case 2, the flow of water would be quicker. सिंपल सी बात है, फिजिक्स में पढ़ चुके हैं that if you increase the gradient, you reduce the friction. If you reduce the friction, then obviously there would be less frictional drag and hence a consequent greater, swifter flow, isn't it? So अगर gradient में ज्यादा फर्क होता है तो flow भी ज्यादा तेज हो. Get it? Similarly, if suppose I have another place, suppose its pressure is, suppose let me hold C, it is 5 MB, then air will blow from C to B as well. That could also happen, right? Because this is high pressure and this is low pressure. Some amount of air might blow from C to A as well. Because relatively speaking, this is high pressure and this is low pressure. Do you get that? So now just imagine that here was B, right? And C would be somewhere here. In this case, the slope would be more steeper. So greater the pressure variance between two places, swifter would be the flow of wind. Got it? It is the gradient which is starting the flow. If there is no gradient means no slope. Suppose I take one more place called D. It has 1 MB pressure. Then will there be any flow between B and D? There won't be any flow between B and D, but immediately there would be a flow between A and D. There would also be a flow between C and D, and obviously you can see the slopes here. That is बनाए ऐसे so that you can see the slopes later on. अब देखो ध्यान से देखो. If I get another place called D, it would be placed here. They are of the same pressure, 1 MB pressure. If they are of the same pressure, there won't be any between the two areas. Got it? That's the first force, pressure gradient force. Pressure gradient force means it is a force which causes a flow of air from high pressure to low pressure. Greater the gradient, faster would be the flow. Simple logic, इसमें कोई rocket science नहीं है. Greater the gradient, faster would be the flow. So I give you two cases. Case 1, air is blowing between 3 MB and 0.5 MB. Case 2, air is flowing between 2 MB and 1 MB. Case 1, case 2. In which case, the air would be faster. 1 or 2? 1, because there is a greater difference in pressure. Now you tell me, the PGF, or the pressure gradient force. It means the force created due to the pressure gradient. That's the PGF. The PGF, will it impact the velocity of the wind? Will it impact the velocity of the wind? Yes. Will it impact the direction of the wind? It will also impact the direction of the wind. If suppose the low pressure area is here, we hold another place which is 2 MB, then air would flow in this direction. Do you understand that? If it is here, then it will flow in this direction. So the pressure gradient force, the learning is, it impacts both the velocity and the direction of the wind movement. Suppose this is the high pressure point. Here you have the low pressure. This is the direction of the wind. There you have the low pressure. This is the direction of the wind. And obviously you can understand that it will have an impact on the velocity as well. What? The gradient. Sorry, is this thing clear to everybody? Let's move to this one, which is more interesting. Yes, go on. Go on.
So, when you give us the two cases, 3 MB and the 0.5, the pressure flow is more. The reason is the because the distribution, the slope would be more. That has to explain the additional.
There I took the slope as an analogy. There is no slope actually because both are present on ground. Got it? I took the slope as analogy. You have to see the difference. Here the difference is how much? Here the difference is 3.5. Isn't it? That's the difference. Whereas here the difference is only 1. Got it? That's why. Greater the difference, faster would be the flow. Clear? Let's move to this one. Coriolis force. But before we go into that, the Coriolis force, we must understand one thing. We know that the Earth rotates, right? And it rotates on its axis. And how does it rotate? It rotates from west to east. But when I see from the North Pole, then it is rotating in anti-clockwise direction. Whereas if I see it from the South Pole, it is rotating in clockwise direction. अब इस understanding को हम लेंगे आज. We will not talk about the west to east rotation of the Earth. Rather, we will talk about the anti-clockwise and the clockwise rotation of the Earth. How does the Earth rotate when seen from the poles? Got it? From the North Pole, it is anti-clockwise. From the South Pole, it is clockwise. ठीक है? अब याद करो that when you were a child, you used to visit parks or something like that, and there was a game called merry-go-round. है ना? एक डिस्क होता था, वो ऐसे घूमता रहता था. बच्चे सीट पे बैठे होते थे और सारे बच्चे उस पे ऐसे मजे कर रहे होते थे शाम को. यही होता था. So let's assume something like that, a merry-go-round kind of thing. ठीक है? This will not be found in books, so pay attention. Let's assume that this is one such rotating disk. Okay, and I am giving you the top view of the disk, and the disk is rotating in a counterclockwise manner. It's a counterclockwise rotation or anti-clockwise rotation. Suppose there is a central point here in this disk. And now let me assume that there are two further points. We hold this as one point, A, and let me draw a line to the central point, and let me hold another point here as B. Sorry? अब ऐसे सोचकर देखो कि एक merry-go-round है, rotating disc है, ठीक है? दो बच्चे बैठे हुए, एक सीट बी पर बैठे हुए हैं और वो ए की तरफ देख रहे हैं, और एक सीट ए पर बैठे हुए हैं जो बी की तरफ, दोनों एक दूसरे को देख रहे हैं, एंड दे आर ट्राइंग टू थ्रो अ बॉल एट ईच अदर. कर देते हैं, ठीक है. एंड लेट्स अज्यूम दैट बी इज ट्राइंग टू थ्रो द बॉल टुवर्ड्स ए. सो बी threw the ball towards A. Let this be the ball. The tennis ball, which is being thrown by B towards A. But by the time the ball reaches A, the disc would rotate, isn't it? So suppose it has rotated, and this is where A is now. This is A's new position. And if this is A's new position, because it is fixed, you can understand this would be B's new position. This would be B's new position. There is something interesting in physics called the law of conservation of momentum. ठीक है, अब इसका मतलब क्या होगा? ऐसे सोचिए. Suppose I have a ball in my hand. अच्छा देखो, suppose I have a ball in my hand, and this is what I'm doing. If I throw it, it will go straight. Okay, or in whatever direction I throw, it will go in that fashion. But suppose I'm running and I'm throwing the ball like this. Do you understand that? So if I throw the ball like this, it won't travel in a straight path. Rather, it will travel like this, because my body's momentum would be transferred to the ball. Okay? Those who have played cricket will relate to it, that as you're picking the ball from the ground and you're throwing the ball towards the stumps, it's not necessary कि आप अगर उसको ऐसे स्टंप की तरफ फेंकोगे तो आगे चला जाएगा. आपको थोड़ा पीछे फेंकना पड़ेगा उसको, because as your body will travel, the ball will also travel the same amount horizontally. You understand that? आप ऐसा जितना move कर रहे हो, if I pick the ball here and I throw the ball like this, do you understand that? And I'm also running, and by the time I leave the ball, the ball leaves my hand. I have already touched the ball here, and now I have picked it. Just imagine the slow motion, and now I'm throwing it like this. So by the time I touch the ball, I am leaving the ball. I've traveled this much distance. The ball has come in contact with my body, has become a part of my body, and it's a complete system. And the momentum now belongs to the entire system. So if the ball will leave the system, it means me and ball system. If it leaves the system, it will carry the momentum because of law of conservation of momentum. तो जैसे कि समझ लो, if I am throwing it like this, it won't travel like this. I picked it like this and want to throw it there. So I picked it like this and I went like this and I threw it like this. It won't go like that. It will go like this. Do you understand that? So whatever distance I travel, the ball will also travel horizontally. Apart from this distance, it will also travel this distance. You get it? समझ में आ रहा है? This is the reason why when you're playing cricket, I mean, if you understand basic physics, you would be a very good fielder. ठीक है? Same thing applies in football as well. अगर आप देखोगे, because of every traveling object will experience this Coriolis force, and we will see that. But anyhow, यहाँ तक बात समझ में आ गई? ठीक है? तो अब देखो that B has traveled to what distance? B has traveled to this distance. You see that? This is the distance that B has traveled. It means this ball will also travel this distance. Do you get it? This would be the new position of the ball. As B has thrown the ball towards A, this is what B has done. This is what B has done. Look here. B has thrown the ball towards A. But by the time the ball reaches A, the disc has rotated. This is A's new position. This is B's new position. Since B has moved, the ball will also move. Do you get it? It will also move the same distance as B has moved because of the law of conservation of momentum. अब देखो एक चीज, B को लगेगा that I threw the ball towards A. B के पॉइंट ऑफ व्यू से इस नए सिचुएशन से सोचने की कोशिश करो. B को लगेगा I have thrown the ball towards A, but the ball has turned towards the right. Do you understand that? This has to be the path. This has to be the path. Do you understand that? But it has turned towards right. ऐसी feeling आएगी B को. But ऐसा actually हुआ है क्या? It has not happened. Do you understand that? It has not happened. It's only the relative positions of A and B that has changed. Look here, very carefully. ये मैं कह रहा हूँ, ये A की position, ये B की position, ये ball है समझ लो. The disc has rotated. This is A's new position. This is B's new position. तो B ने अगर इतना distance travel किया है तो ball भी उतना ही distance travel करेगा. अब B के point of view से देखो तो B को लगेगा कि मैंने A की तरफ फेंका है ये ball. Do you understand that? But बॉल कहां पर है? यहां पर है. तो बी को लगेगा कि मैं तो सीधा फेंक रहा था पर ये इधर क्यों जा रहा है. बी के पर्सपेक्टिव से देखने की कोशिश करो. ये उसका राइट हुआ कि नहीं? बी का राइट हुआ, ये बी का लेफ्ट है. सो बी विल गेट अ फीलिंग दैट आई थ्रू द बॉल स्ट्रेट बट बॉल हैज टर्न टुवर्ड्स द राइट. यू अंडरस्टैंड दैट? आप इसको दूसरी कंडीशन में भी देख के कर सकते हो. ऐसे समझ कर देखो. लेट्स होल्ड सम मोर सिनेरियोस. Let us assume this is A's position, this is B's position. This time A is throwing the ball towards B. Got it? A ने कैच किया, A ने वापस थ्रो करने की कोशिश की. So here is where the ball is. This is the intention to throw. But by the time the ball reaches B, you can understand the disc might have rotated. This is A's new position, and if this is A's new position, then this must be B's new position. Do you understand that? And by the law of conservation of momentum, it says what? That जितना distance A ने travel किया है, उतना ही distance ball भी travel करेगा. So ball will also travel the same distance like this. यही distance जो ये वाला distance है, ये वाला distance ball भी travel करेगा इधर. By law of conservation of momentum. So where would be the ball? Here. Do you understand that? अब A के perspective से देखो. A को लग रहा है that I have thrown the ball towards B. This is B's new location. This is A's new location. I have thrown the ball towards B. But where is the ball? It is here. It means rather than going like this, it has turned towards the right. समझ में आ रहा है? समझ में आ रहा है? It would not be found in the books. I'm telling you one more time. This is the Coriolis effect. It means things moving in the northern hemisphere turn towards their right. किताब में आपको एक ही लाइन लिखी हुई मिलेगी. Things moving in the northern hemisphere turn towards their. Why does that happen? We have to take a look at it from the perspective of a anti-clockwise rotating disk. And when seen from the North Pole, the Earth rotates how? Anti-clockwise. Therefore, in the northern hemisphere, every moving object will turn towards its right. And when I say moving object, I include winds. I include the ocean currents as well. You understand that? इसलिए आपने कई बार देखा होगा कि बच्चे जब एक दूसरे को ऐसे बॉल फेंकते रहते हैं, बॉल बार बार इधर जाती है, राइट में चली जाती है. अगर डिस्क रोटेट हो रहा है तो द चिल्ड्रन कंप्लेन ऑल्सो कि तुमको खेलना नहीं आता. You understand that? But actually, it is happening due to Coriolis. Coriolis is not a real force. There is no energy involved in this. It's just an apparent force. मतलब हमको ऐसा लग रहा है कि it has turned towards its right, but it has not actually turned towards its right. So when we say turn towards its right, we see it from the perspective of the person and not from the perspective of the observer. हमारे ऑब्जर्वर के पॉइंट ऑफ व्यू से नहीं है, लेकिन जब हम ए का पर्सपेक्टिव लेंगे या बी का पर्सपेक्टिव लेंगे तभी हमको लगेगा दैट इट हैज टर्न टुवर्ड्स देयर राइट. सो एनी मूविंग ऑब्जेक्ट इन द नॉर्दर्न हेमिस्फीयर टर्न टुवर्ड्स इट्स राइट, नॉट द ऑब्जर्वर्स राइट. ठीक है, समझ में आ रहा है? जैसे कि आप बैठे हो इस पर्सपेक्टिव से अगर आप देख रहे हो तो आपका राइट तो ये है ना, बट इफ a wind is moving like this in the northern hemisphere, it will turn towards its right. समझ में आया? Any moving object turn towards its right and not the observer's right. समझ में आ गया ये बात? अब एक बात बोलो, if I rotate this disk quickly, if I increase the speed of rotation, the deflection would be more or less? More. समझ में आया? So faster the wind, greater would be the deflection. Greater would be the deflection towards the right. ठीक है? If I just take the same thing and I compare it in the southern hemisphere, ऐसे देख लो, in the southern hemisphere the rotation is clockwise, so I'm holding it a clockwise rotation, and suppose this is the center, and then let me hold, this is point A, suppose this is point B, And again, I'm assuming that B is trying to throw a ball towards A, but by the time the ball reaches A, this is A's new position. Here is where A is. If that's the scenario, that's the scenario. Let me hold this as B's new position. This is B's new position. But because B has traveled this much distance, the ball will also travel this much distance. You get it? Here would be the new location of the ball. So B will get a feeling that I have thrown the ball towards A, but the ball has deflected to the left. B is left. समझ में आ रहा है? आप इसको A से B को भी थ्रो करवा के देख लो, तब भी यही होने वाला है. चलो करके देख लेते हैं. If suppose this is A's position, this is B's position, और ये ऐसे डिसरोटेट हो रहा है. Suppose A is throwing the ball towards B. इतना पकड़ लो इसको. Now the disc has rotated. This is suppose A's new position. This is B's new position. Since A has traveled this distance, the ball will also travel the same distance. Do you understand that? Now look from A's perspective. A को लगेगा I have thrown the ball towards B, but where is the ball? Here is the ball. It means the ball has turned towards the left. समझ में आ रहा है? This is Coriolis. This is the beauty of Coriolis. Coriolis impacts everything that is moving over the surface of the earth. In the northern hemisphere, it will turn towards its right. In the southern hemisphere, it will turn towards its. तो बात clear हो गई? ठीक है. Now this phenomena is known as the Ferrel's law. That all moving objects turn towards its right in the northern hemisphere, turn towards its left in the southern hemisphere. This law is known as the Ferrel's law, and this effect is known as the Coriolis effect. It happens due to the rotation of the earth on its own axis. ठीक है? Faster the rotation, greater would be the deflection. It means, can I say very clearly, faster winds will deflect more and slower winds will deflect. ठीक है. अच्छा, एक चीज और देखो ध्यान से. What would happen at the equator? Why? Why? अच्छा, एक बात बताओ. The earth rotates from west to east. From the north pole, it rotates anti-clockwise. South pole, it rotates clockwise. जब आप नॉर्थ पोल की तरफ से देख रहे हो तो आपको इक्वेटर तो दिखेगा ना. पूरा नॉर्दर्न हेमिस्फीयर देखोगे तो उसका एंड क्या होगा? इक्वेटर होगा. Do you understand that? So you tell me that how is the equator rotating here? How is the equator rotating here? समझ में आ रहा है? If I am rotating something anti-clockwise and clockwise together, it means there is no rotation. समझ में आ रहा है ना? दोनों they are cancelling out each other. If they are cancelling out each other, then आप ऐसे सोच कर देखो. If they are cancelling out each other, there is no rotating disc, and this is B's position, this is A's position. B will throw the ball will be here. The disc is not rotating. समझ में आ रहा है? That's why at the equator the Coriolis is 0. You will find that Coriolis force is necessary for the formation of tropical cyclones. That's why at the equator there is no tropical cyclone. Why no tropical cyclone? Because the Coriolis force is 0. समझ में आ रहा है? अगर आपको Coriolis का ये लॉजिक समझ में नहीं आया तो मैं आपको और भी एक सिंपल सा लॉजिक बताता हूँ. ठीक है? आप ये मान के चलो कि ये क्लासरूम जो है ये रोटेट हो रही है. ठीक है? Assume that it is rotating counterclockwise. And suppose I am standing at this corner, and suppose a person is standing at that corner of the room. It means we are standing diagonally opposite to each other. And let's assume that instead of having a cubical shape, this room has a circular shape. Okay, it's a circular rotating disc. समझ में आ गया? ऐसा ही कुछ है. Suppose I have a ball at my hand. I have a ball at my hand. Okay. And I'm throwing it to that person who is standing diagonally opposite to me. Okay? Now, if I throw to that person, the disc is rotating. Do you understand that? So disc has rotated. By the time the ball reaches him, I am somewhere here, and that person is somewhere there. You understand that? पर बॉल तो हवा में है ना. आप ऐसे सोच कर देख रहे हो, बॉल तो हवा में, वो तो अपनी पाथ को ट्रैवल करेगा. तो मुझे क्या लगेगा, मैंने इनकी तरफ फेंका, गेंद उधर कैसे है? You give an impact as if I have thrown it straight, but it has turned towards my right. ये बड़ा ही देसी अंडरस्टैंडिंग है कोरियोलिस का, बट ये एक टेक्निकल अंडरस्टैंडिंग है कोरियोलिस. यू गेट इट? इसमें मैंने लॉ ऑफ कंजर्वेशन ऑफ मोमेंटम वगैरह सब बिल्कुल समझ रहे हो ना, ताक पे रख दिया, कुछ भी नहीं कंसीडर किया. यहाँ पे मैंने सारी चीजें कंसीडर करी है और इससे पाया दैट द कोरियोलिस gives a change in direction to the wind, and that direction is towards the right in the northern hemisphere, towards the left in the southern hemisphere. अब मैं आपसे कुछ बातें पूछ रहा हूँ, आप बताएंगे. I am in the northern hemisphere. This is how the wind will blow. So this is how the wind was blowing. This is actually the wind would blow. Am I correct on this observation? Suppose the wind is moving like this in the northern hemisphere. This is the designated path, but actually the movement would be like this. Are you with me on this? Why? Because it is not to the observer's right, but to the object's right. Wind यहाँ पे object हो गया हमारे लिए. If we are in the southern hemisphere, this is how the wind is blowing its designated path. It would actually blow like this. Can you understand that? To its left, if I'm in the southern hemisphere, the wind is blowing like this. It will actually blow like this. This is known as the Farrell's law. ठीक है? एक और law है, which is the Bias-Ballot law. If I stand with my back towards the wind, okay, the wind is blowing on my back or on my shoulders, suppose, and I'm standing in the northern hemisphere. Do you understand that? If I hold both my hands like this, obviously wind will have some pressure over my hands as wind is blowing in this direction. Which hand would experience more pressure? The right hand or the left hand? Why? Because every moving object in the northern hemisphere will turn towards its right. तो जो wind मेरे पीछे से आ रही होगी वो कैसे होगी? थोड़ी right की तरफ जाएगी. समझ में? तो मैं अगर ऐसे खड़ा हूं तो my right hand would experience more pressure. If I am in the southern hemisphere, then left hand would experience more pressure. अच्छा, आपने वो देखा होगा बचपन में ऐसे कुछ हम खेलते थे. ऐसा कुछ होता था, इसको लेकर भागते थे, ये घूमता था, याद आ रहा है? जो भी बोलते हम इसको चक्री बोलते थे, पता नहीं आप क्या बोलते थे इसको, जो भी है, ठीक है. तो समझ लो मैंने ऐसे दो चक्री पकड़ी हुई है, ठीक है, और ऐसे खड़ा हूं मैं नॉर्दर्न हेमिस्फीयर. तो हवा के मूवमेंट से ही ये घूमता था, तो मैं इसको लेकर भागता तो हवा ही उसको काटती थी ना, तभी वो घूमने लगता था. नथिंग बट सिंपल फिजिक्स है और कुछ भी नहीं है. तो ऐसे देखो, अगर मैंने दो ऐसे पकड़ के खड़ा हुआ हूँ नॉर्दर्न हेमिस्फीयर में, तो कौन सा वाला तेज घूमेगा, राइट हैंड वाला या लेफ्ट हैंड वाला? कौन सा तेज घूमेगा? राइट हैंड वाला, क्योंकि ज्यादा हवा है ना वहां, ज्यादा एनर्जी है ना, तो ज्यादा एनर्जी है तो रोटेशन स्पीड भी ज्यादा होगी. डू यू अंडरस्टैंड दैट? इसलिए बच्चे जब खेलते थे आप देखोगे तो जो राइट हैंडेड बच्चे होते थे, मोस्टली चिल्ड्रन आर राइट हैंडेड, तो राइट हैंड में लेकर दौड़ते थे, राइट हैंड में लेकर दौड़ते थे, तो वो बहुत तेज से घूमते थे. और जो लेफ्ट हैंडेड बच्चे होते थे उनका वाला घूमता नहीं था उतना तेज, तो वो फेंक देते थे, ये खराब है मेरा वाला. दूसरा उठाते थे, वो भी खराब है, तीसरा भी खराब है. लेकिन सदर्न हेमिस्फीयर में जाओगे तो लेफ्ट हैंड वाले जीत जाएंगे, राइट हैंड वाले हार जाएंगे. नॉर्दर्न हेमिस्फीयर इज राइट हैंडर्स हेमिस्फीयर, सोच कर. सदर्न हेमिस्फीयर इज लेफ्ट हैंडर्स, ठीक है. एंड फॉर सम स्ट्रेंज रीजन right is always given a kind of partial treatment. आप ऐसे देख लो, डे टू डे लाइफ में भी अगर आप देखोगे तो राइट को हमेशा पार्शियल ट्रीटमेंट मिलेगा. आप बाइक में एक्सीलरेटर देखो, राइट की तरफ लगा. अब दरवाजा देखो ऐसे खुलता है, आप किताब देखो ऐसे पलटता है, समझ में है? आप ये कुर्सियां देख लो, तो ये राइट हैंडर्स बायस्ड वर्ल्ड है, ठीक है. एनी मोर ऑफ इट सम डे लेटर. समझ में आ गई ये बात? That is the Coriolis force. So now my question is, Coriolis force impacts the velocity of the wind. Is it true? False. it's an apparent force. मैंने पहले ही बताया आपको velocity कैसे change कर देगा. It is not putting in any energy. Does it impact the direction of the wind? Yes, it does not impact the velocity of the wind. What about the pressure gradient force? Velocity? Yes. Direction? Yes. Now let's try to understand the third force, which is frictional force. बड़ा आसान है ये तो समझना. Suppose I have two surfaces. This is surface 1 and this is surface 2. ठीक है? This is a plane surface. ऐसे surfaces को geography में technical भाषा में कहते हैं penny planes. ठीक है? But अभी आप ऐसे समझ लो इसको plane बोलो. ठीक है? And this is an undulating topography or a hostile terrain. कुछ भी बोल सकते हैं. ठीक है? अब एक बात बताओ. Wind is blowing from point A to B. Here the wind will blow unhindered, isn't it? And suppose the velocity of the wind here is v1. Here suppose we have point C and D, and wind is blowing between C and D. It will be obstructed by the mountain first, so it will be forced to rise. Then it will, under the impact of gravity, it will come down. Again it will be obstructed. It will be forced to rise. Again it will come down under the impact of gravity. It will be obstructed. It will keep on rising. Again it will come down, and that's how it will reach D. You understand that? Its velocity, let's assume average velocity. वैसे तो velocity हर section में change होती रहेगी. Average velocity is v2. You tell me v1 would be more or v2 would be more? Which would be more? v1 would be more because there is no frictional resistance. हर बार जैसे वो wind टकराएगी पत्थरों से, तो आपको पता है पत्थर will take some energy out of the wind, isn't it? If that's the scenario, then you can very well understand this, that the frictional force reduces the velocity of wind, isn't it? Greater the topographical variations, greater would be the frictional drag, isn't it? अब ध्यान से देखो एक चीज. I have winds blowing on the land surface, and I have winds blowing at the upper level of the atmosphere. Let's assume only troposphere. So I have two sets of winds, upper air advection and ground advection. So upper air advection, चलो इसकी डायरेक्शन ऐसे कर लेते हैं for sake of more clarity. अगर ये ऐसे बह रही है तो ये ऐसे बहेगी. Got it? Now look here very carefully. Here suppose the velocity is v1. Here the velocity is v2. Which one is correct? Why? Because there is no frictional drag or less friction. Air would create less friction when compared to land. Do you get it? And if the wind is blowing over oceans, blowing over deserts, it will be faster. आपने देखा भी होगा, gale winds blow over the oceans and the desert. Desert storm आता है ना? But शहरों में क्या होता है? There is structures, there is natural barriers. That's why a lot of frictional drag, and that reduces the. So if I talk about the frictional force, does that impact the velocity of the wind? Yes, obviously. तो देख ही रहे हैं. It impacts the velocity of the wind. Does it impact the direction of the wind? Yes, it will obstruct and it will change the direction of the wind. So it also impacts the direction of the wind. It is the Coriolis force only force which does not impact the velocity. और जब velocity में कोई change नहीं आ रहा है, force लगाने के बाद भी ज़्यादा या कम नहीं हो रहा है, तो आप समझ लो force है ही नहीं. It's only an apparent effect. समझ आ रहा है? जैसे कि लोगों को कई बार perception होता है और कुछ reality होती है. Perception, if it matches to reality, then it's a good analysis. If perceptions are away from reality, then it's a very bad analysis. समझ में आ रहा है? तो वैसे ही है कि यहाँ पर velocity का कोई impact ही नहीं change हो रहा, उसका मतलब ये force है ही नहीं, ये बस एक appearance है कि ये एक force है, but ये real में कोई force नहीं है. Forces are of two kinds, real forces and apparent forces. So Coriolis force is an apparent force, it is not a real force. What about PGF? Is that a real force? जो भी velocity को impact कर देगा वो real force होगा. What about frictional force? Is that a real force? That's a real force. Do you understand that? So these are the three forces or the three factors that impact the wind movement. और इसमें आपको क्या ध्यान में रखना है? Ferrell's law. What is Ferrell's law? Every moving object in the northern hemisphere turn towards its right. Every moving object in the southern hemisphere turn towards its left. This is due to the Coriolis force. Coriolis force is the force generated due to the rotation of the earth, and it is actually not a force but an apparent force. It only impacts the direction and does not impact velocity in any manner. ठीक है? अब बड़े ध्यान से देखो एक चीज. Suppose I have two isobars. This is isobar, say 1 MB, and this is isobar 3 MB. Can I say this is high pressure, whereas this one is low pressure? And wind always blows from high pressure to low pressure. So suppose I am in the northern hemisphere, then this is what should happen. The wind should blow like this from high pressure to low pressure. But ऐसा होगा क्या? No, the wind will actually blow like due to Coriolis. समझ में आ रहा है? If the wind is blowing from here to here, suppose एक और ले लेते हैं हम. Let's assume ऐसे. Let's assume this is 1 MB and this one is 0.5 MB. Now this is high pressure, this is low pressure. The wind should blow like this, but will it blow like this? No, it will blow like this. If I am in the northern hemisphere, अगर southern hemisphere में चले जाऊँ मैं तो ये चीजें left की तरफ हो जाएंगी. Do you understand that? Now, tell me one thing, that if this pressure difference is in the upper atmosphere and this pressure difference is on ground, मतलब दो set of systems ले लिया मैंने, एक on ground, एक upper atmosphere. कहाँ पे wind तेज होगी? Why? Because there is no frictional drag. And I told you one thing, faster the wind, greater would be the deflection. समझ में आ रहा है? तो ध्यान से देखो. Suppose we are in the upper atmosphere. In the upper atmosphere, we have a great variability in the pressure position. Suppose this is 10 millibars. So होता नहीं है, just for the sake of understanding मैं कह रहा हूँ. And this is 1 millibar. So this is extreme high pressure and this is extreme low pressure. So the wind would gush. It would go very swiftly. And faster the wind, greater would be the deflection. So look here, this is its designated path. But due to its speed, the wind would go like this. You get deflected a lot. It will never reach there. समझ में आ रहा है? ये डिफ्लेक्ट ही हो गया पूरा. समझ में आ रहा है आपको? जैसे हमने फिजिक्स में कॉन्सेप्ट पढ़ा था कभी, मतलब मेरे साथ नहीं पढ़ा, आप लोगों ने कभी वैसे पढ़ा होगा, द कॉन्सेप्ट ऑफ क्रिटिकल एंगल. पता है ना? क्रिटिकल एंगल पे ही आप इसको इंसिडेंट करोगे तभी ये डिस्पर्जन होगा. एंड देयर इज समथिंग कॉल्ड, अगर आपने फाइबर ऑप्टिक केबल कभी पढ़ा, सो देयर इज समथिंग कॉल्ड व्हाट, सबसे पहले क्या होता है फाइबर ऑप्टिक केबल पे? क्या होता है सबसे अंदर? उसके कोर, कोर होता है ना. कोर के ऊपर क्या होता है? क्लैडिंग. और उसके ऊपर क्या होता है? बफर. ठीक है, जो पीवीसी पाइप्स होते हैं. खैर जो भी है छोड़ दो, तो पुरानी बातें हैं, क्यों दोहराना. अब देखो, you know there is something called total internal reflection. Total internal reflection is always when the ray of light is incident at a critical angle. उसके ज्यादा, उसके आगे आप जाओगे तभी total internal reflection होने लगेगा. You understand that? And total internal reflection की वजह से ही fiber optic communication possible है. And this travels very fast. Speed of light मैंने आपको बताया भी है कि वो सबसे तेज है. तो if we are in the upper atmosphere, the winds are very fast, and due to their fastness, they curve like this. You understand that? And they start blowing parallel to the isobars. This is 1 MB isobar, this is 10 MB isobar, and the wind is blowing parallel to the isobars. ऐसे देखोगे upper air में ऐसे ही होगा. ठीक है, तो this is the 10 MB isobar, this is the 1 MB isobar. The wind should go like this. पर वो कैसे जा रहा है? It's parallel to the isobars. You understand that? Such kind of winds are known as geostrophic winds. और हम देखेंगे that jet streams are a type of geostrophic winds with some variation. ठीक है, और jet stream की understanding भी आपको चाहिए in order to understand the atmosphere and in order to understand the Indian monsoons. Okay, यहाँ तक बात clear हो गई. तो चलो एक और. Pressure belts.
Yes, sir.
We'll talk about that, dear. Don't worry.
No, sir, I was saying This figure which you are saying that it is going from a high pressure to low pressure. Can you show your applications like practical representation of the
With the help of like a pressure belt, you are saying.
yes,
But pressure belts are actually, they have a global presence. Pressure belt is a technical term. You should not use the term pressure belt, rather you can use the term pressure zone, okay, or pressure section. But pressure belts are global belts, like the equatorial low pressure belt or the subtropical high pressure belt. बेल्ट जब हम बोलते हैं, बेल्ट कैसे होगा, बेल्ट इतना छोटा थोड़ा ना हो सकता है, वो तो पूरे में आएगा ना. That's why it is known as pressure belt. Pressure belt is a technical term, but sometimes loosely you can use it. मेंस एग्जामिनेशन में कभी यूज करना है तो ठीक है. यहाँ पे बात क्लियर हो गई. अब एक और चीज समझेंगे हम, the role of moisture in the atmosphere, and then after that I'll leave you people, but we will meet again in one more class, and that is very important क्योंकि ये सारे concepts मैं वहाँ पे use कर रहा हूँ. ठीक है, अभी तो मैंने आपको बहुत आसानी से इनको समझा दिया, वहाँ पे थोड़ा तेज चलेंगे. And I'll give you one sheet for the day which will be combined for both the classes. ठीक है, तो चलो देखो अब एक चीज, what is moisture? Moisture, अच्छा इसका मतलब क्या होता है? What is the difference between moisture and humidity? Is there any difference between moisture and humidity, or are they the same? Okay, what about water vapor? Water vapor, moisture, humidity, are they the same? They are used interchangeably most of the times. ठीक है, but थोड़ा सा variation है दोनों. ठीक है, ह्यूमिडिटी जब भी हम यूज करते हैं, इट इज ऑलवेज इन टर्म्स ऑफ सम प्रोपोर्शन. मॉइस्चर इज अ जनरल टर्म व्हिच इंडिकेट्स द अमाउंट ऑफ वाटर वेपर प्रेजेंट इन एयर. यू गेट दैट? अब ध्यान से दैट suppose this is a air parcel, and obviously you know air parcel means it's a combination of what? It's a combination of gases, dust particles, and water vapor. You understand that? So the amount of water vapor present in an air parcel is the humidity. You understand that? Or the moisture in the air. मैं जनरली बोल रहा हूँ इसको, उसके कुछ टेक्निकल वेरिएशंस भी हैं, बट ऐसे समझ कर देख लो. द अमाउंट ऑफ वाटर वेपर प्रेजेंट इन द एयर इज नोन एज ह्यूमिडिटी. यू गेट इट? अब एक चीज ध्यान से देखो, दैट द air parcel's capacity to hold moisture depends upon the temperature of the air parcel. Hotter the temperature, greater is the moisture holding capacity. आपने पढ़ा है कहीं? आपने हमेशा पढ़ा होगा hot and moist air parcel, cold and dry air parcel. ये होता है ना? The summer season is how? It is a hot season, but it is also a season when there is good amount of moisture present in the atmosphere, especially the late summers. Think of June, July, when the monsoons strike here. Do you get it? But how are the winters? Winters are cold air and dry air. And that's why आप देखोगे कि आपके चेहरे से भी या हाथ से भी कहीं भी आप देखोगे वो moisture चला जाता है. And that's why if you just draw lines, you will get some white lines over your hand because the moisture is gone. That's why winters में moisturizers बिकते हैं. अब समझ में आ रहा है? ध्यान से देखो अब इस चीज को. Why hot air can hold more moisture? This is also इतना लिखा होता है किताबों में. Hotter the air, greater its moisture holding capacity. But how and why? ऐसे सोच कर देखो. When the air parcel receives heat, is there an expansion in its volume? If there is an expansion in its volume, it means there is a increasing gap now in the intermolecular spaces, or the molecules are moving away from each other. अगर ऐसा होगा, so then you can understand there is intermolecular gap that is increasing, and water vapor occupies those gaps. जगह तो होनी चाहिए ना उसको अंदर जाने के लिए. समझ में आ रहा है? But you see this, that the temperature of the air therefore has a direct correlation with the moisture holding capacity of the air parcel. Hotter the temperature, greater is the moisture holding capacity. What is moisture or humidity? It is nothing but the amount of water vapor present in an air parcel. Hotter the air parcel, greater it is moisture holding capacity. ऐसा लिखा होता है किताब में, ठीक है. अब एक चीज देखो, do you remember what is air pressure? Air pressure was nothing but the pressure exerted by a unit column of air when drawn from the surface to the top of the atmosphere. This is the Earth's surface. This is the atmosphere, all the layers of the atmosphere. And let's assume this is a place A. And I draw a unit column of air. ठीक है, हो सकता है 1 सेंटीमीटर 1 सेंटीमीटर 1 सेंटीमीटर ऐसा कोई एक आप समझ लो रेक्टेंगुलर है कोई सेक्शन, ठीक है. So this is, here you would have the exosphere, thermosphere, mesosphere, stratosphere, troposphere. And actually this would contain what? It would contain water vapor, gases and dust particles. All of that would be present there. ये तीनों मिला के अपना एक weight तो होगा इनका. That weight would be exerted over what? Over the point A. And that weight will create pressure. And that pressure is known as atmospheric pressure. या मैंने आपको बताया था atmospheric के लिए एक और term जो use होता है, that is air. That is also known as air pressure or atmospheric pressure. ठीक है. अब एक चीज देखो कि if I discount gases and dust from this column, कि जितना भी total weight हो रहा होगा, समझ लो total weight जो है वो इतना है, समझ लो 500 grams ऐसे समझ लो, ठीक है. इतना टोटल वेट है. तो इस 500 ग्राम्स में डस्ट का वेट भी होगा, गैसेस का वेट भी होगा और वाटर वेपर का वेट भी होगा. समझ लो गैसेस का वेट इतना है 450 ग्राम्स, वाटर वेपर का इतना है 40 ग्राम्स और डस्ट पार्टिकल्स का इतना है 10 grams. You understand that? So if from the total pressure I subtract the pressure exerted by the gases and the dust particles, I get the pressure exerted by vapor only. That is known as vapor pressure. Vapor pressure is nothing but the pressure exerted by vapor in a unit column of air. या आप ऐसे सोच कर देखो, total pressure कितना हो गया 500, and from 500 if I subtract the pressure exerted by gases, what is it? 450. What is the pressure exerted by dust particles? 10. So what do I get? That is actually the pressure exerted by water. You get that? So that is known as vapor pressure. When we talk about atmospheric pressure, you see, let's suppose you are standing on ground. This is how you are standing. Let's assume that you would experience an air pressure over your head, ठीक है. और इस प्रेशर की वजह से क्या हो जाना चाहिए, आपको बैठ जाना चाहिए. You won't be able to walk because ये प्रेशर अच्छा खासा प्रेशर होता है, पूरे एटमॉस्फेयर का है, समझ में आ रहा है. और वो उसका डिस्टेंस क्या है, डू यू रिमेंबर? 29,000 किलोमीटर. और वो अगर पूरा स्ट्रेच में देखो और आपका हाइट देखो जो भी है, इट वुड बी ऑलमोस्ट नेग्लिजिबल. आप ये सोच कर देखो, तो इस प्रेशर की वजह से आप ये प्रेशर क्यों नहीं फील करते? मतलब लाइक यू आर मूविंग फ्रॉम वन प्लेस टू अनदर, यू वोंट फील दैट प्रेशर. व्हाई? बिकॉज इनसाइड योर बॉडी देयर आर सम आर्टरीज एंड वेन्स. उससे क्या बह रहा है? ब्लड, है ना. तो ब्लड का भी अपना एक प्रेशर है, या आपके इंटरनल बॉडी का भी एक प्रेशर है. दिस प्रेशर बैलेंसेस दैट प्रेशर. यू गेट इट? और रिजल्टेंट क्या होता है? जीरो. दैट्स व्हाई यू डोंट फील द प्रेशर. अब एक चीज देखो, ऐसे सोच कर देखो, प्रेशर इज एक्चुअली अ फोर्स, ठीक है. सो आई हैव टू फोर्सेस, दिस इज F1 and I have another force, this is F2, ठीक है. I have an object F2, I have an object F1, ठीक है. और ये forces है दोनों, they are moving towards each other. Now look here very carefully. If I say F2 is greater than F1, the resultant movement would be in this direction. Can I say? If I say F1 is more than F2, the resultant movement would be in this direction. But if I say F1 is equals to F2, can I say there would be no movement? Because both the forces have cancelled each other. Resultant तो कोई आएगा ही नहीं इसमें. You get it? समझ में आ रहा है ना? ऐसे जैसे हम नहीं पढ़ते थे, this is F1, if this is F2, then the resultant force would be like this. This would be the resultant. समझ में आ रहा है ना? तो अब एक चीज देखो यहाँ पर, अगर ये प्रेशर है which is atmospheric pressure, there is some internal body pressure which is your blood pressure. ऐसे समझ कर देखो, your BP balance is your atmospheric pressure. ठीक है, और इसकी वजह से you don't feel any kind of pressure over your head. ध्यान से देखो, suppose a person is standing here at the mean sea level. Let me hold this as the mean sea level. Then at mean sea level, this is what happens. The atmospheric pressure is balanced by the internal body pressure. That's why you don't feel any kind of pressure. ठीक है, तो अगर मैं इसको मानता हूँ force F1, इसको मानता हूँ force F2, F1 and F2 are balanced. That's why you don't feel any resultant pressure. अब ध्यान से देखो, let's suppose let me hold some heights. This is H1 from the mean sea level. There's another height H2 from the mean sea level. और इसको भी ले लेते हैं H3 from the mean sea level. ठीक है? Suppose this person is climbing the slope. If he comes here, then internal body pressure remains constant. वो थोड़ी ना चेंज हो जाएगा, ऐसा थोड़ी ना कि जब आप माउंटेन क्लाइंब करोगे ज्यादा खून आ जाएगा आपकी बॉडी, तो नहीं रहेगा, वही प्रेशर रहने वाला है. ठीक है, but what happened to this pressure? What happened to F1? Now it has reduced. You understand that? Let me hold this as F1 dash. That's the new pressure. Okay, because ये distance भी तो कम हुआ है ना, तो अगर distance कम हुआ होगा तो total weight भी कम हुआ होगा, pressure भी कम हुआ होगा. So now in this case, because F2 is equals to F1 and F2 is equals to F1, ये तो हमने देख लिया, and F1 is more than F1 dash. If that's the case, F2 is equals to F1, F1 is more than F1 dash, can I say F2 would be more than F1 dash? A equals to B, B equals to C, A equals to C. Simple logic. समझ में आ रहा है ना? If that's the case, then F2 here would be more than F1. मतलब internal body pressure जो है ज्यादा हो जाएगा atmospheric pressure के लिए. और आपको पहले ही मैंने बताया कि जहां पे प्रेशर ज्यादा होगा, if F2 is more than F1, then the resultant movement would be in this direction. तो आपके अंदर बॉडी के जो भी फ्लूइड्स हैं वो बाहर की तरफ आने की कोशिश करेंगे. यू अंडरस्टैंड दैट? तो क्या होगा, जैसे कि अगर किसी ने माउंटेनियरिंग नहीं करी है तो आपको पता होगा कि जैसे आप माउंटेनियरिंग थोड़े हाइट पे जाओगे, बेस कैंप बनता है, कुछ ऐसा पता है? जैसे हिमालय का जो बेस कैंप है वो अच्छी खासी हाइट पे है, क्योंकि अगर आपको एवरेस्ट चढ़ना है तो बेस कैंप भी काफी ऊपर लगेगा उसका, कि पहले आप वहां तक तो आ जाओ, फिर उसके बाद देखेंगे आप जा सकते हो कि नहीं वहां. तो जैसे आप ऊपर चढ़ोगे ना, तो सबसे पहले क्या होगा, आपकी सांस थोड़ी थोड़ी फूलेगी, फिर धीरे धीरे और ऊपर चढ़ोगे तो आपकी आंखें और कान में, नाक में आपको प्रेशर फील होगा, जैसे अंदर से कुछ फ्लूइड बाहर आना चाहता है. आप थोड़ा और ऊपर चढ़ोगे तो आपके नाक से खून आने लगेगा. यू अंडरस्टैंड दैट? बिकॉज द फ्लूइड वांट्स टू कम आउट ऑफ योर बॉडी. आप और ऊपर चढ़ोगे तो आपके कान से भी खून आने लगेगा. यू अंडरस्टैंड दैट? अगर आप और ऊपर चढ़ जाओगे, इफ यू आर नॉट अ प्रैक्टिस, मतलब आपने प्रैक्टिस नहीं करी है ठीक से कि लो प्रेशर कंडीशंस में कैसे ऊपर चढ़ते हैं, आपकी आंखों से भी खून आने लगेगा. तो आप डर सकते हो देखकर खुद को कि क्या हो रहा है मेरे साथ. एक्चुअली इट इज नथिंग बट फॉल इन एटमॉस्फेरिक प्रेशर सक्सेसिवली, बट द बॉडी प्रेशर रिमेन्स कांस्टेंट. दैट्स व्हाई माउंटेनियर्स अगर आप देखोगे तो वो ऑक्सीजन लगा लेते हैं जैसे वो ऊपर जाते हैं. ठीक है, वो ग्लासेस पहन लेते हैं, आपने देखा होगा, इससे कि वो बच सके, वो कानों को कवर कर लेते हैं. यू गेट इट? दैट्स व्हाई माउंटेनियरिंग इज वन ऑफ द टफेस्ट टास्क्स एंड इट इज नॉट एवरीबॉडीज. ठीक है, समझ में है? और ये क्यों हो रहा है? बिकॉज विद इंक्रीज इन हाइट द एयर बिकम्स मोर एंड मोर रेरिफाइड. समझ में है? This is where we close as far as this class was concerned. I'll see you again in say half an hour's time, 11 a.m. We are meeting again and we'll pick the threads from here. Thank you very much. Good morning.